Ever needed to expose Python functions as remotely callable tools while maintaining clean, type-safe code? We'll implement a basic greeting tool using FastMCPs at MCP tool decorator, showing how it transforms a standard Python function into an AI callable tool with automatic validation and schema generation. You'll see how type hints define both the interface and runtime checks, while docstrings serve as human-readable documentation and AI-visible descriptions, all working seamlessly across transports like STDIO and HTTP.
At MCP, tool. Def conditional greet name, SDR number int, SDR. Agree to user only if number 10. Return F hello, name, your number is number.
This demonstrates FastMCP's declarative tool exposure pattern, where the @MCP tool decorator transforms standard Python functions into remotely accessible operations while maintaining their native callability. The decorator preserves the function's type hints for automatic parameter validation and uses the docstring as both human documentation and machine-readable interface description, creating self-documenting tools that work consistently across different transports. The distinctive aspect is how a single function definition serves as both implementation and interface specification, without requiring separate root definitions or serialization code. The pattern works by treating decorated functions as complete interface contracts, where FastMCP's runtime inspects the function signature to generate execution schemas. The framework automatically handles parameter validation, transport serialization, and response formatting, while your code remains pure business logic without framework-specific modifications. This specific example shows the simplest form, a synchronous function with typed parameters that returns a formatted string, demonstrating how basic Python functions become remotely callable tools through metadata inspection rather than code modification. This approach eliminates RPC boilerplate while maintaining Python's native type safety and execution semantics. By using standard function definitions with added decorators, you avoid writing manual validation, root handling, or transport-specific code. The pattern excels when you need to expose backend functionality to multiple clients or transports, as the same decorated function works for both direct Python calls and remote execution through FastMCP's supported protocols. The trade-off is adopting FastMCP's convention-based design, but the benefit is a unified system where tool exposure requires minimal additional syntax beyond normal Python function definitions. Let's break it down line by line.
At MCP, tool. Def conditional greet name, SDR number int, SDR. Agree to user only if number 10.
The @MCP tool decorator exposes this Python function as a remotely callable tool, using type hints to generate a runtime-validated schema while treating the docstring as both human documentation and the tool's AI-visible description. FastMCP handles all serialization and transport automatically, enabling the same function to work identically for direct Python calls or remote execution via STDIO, HTTP, or other transports. This pattern creates self-documenting interfaces where the function signature serves as both implementation and contract, with the decorator eliminating manual root definitions while maintaining type safety across all execution modes.
Return F hello, name, your number is number.
This @MCP tool decorator exposes the function as an AI callable tool, using Python type hints to generate a validated schema and the docstring as both human documentation and the AI visible description. The decorator handles all transport concerns, serialization, validation, and routing, so the same function works whether called directly in Python or remotely via HTTP, STDIO, or other transports. The function signature serves as both implementation and interface definition, creating a self-documenting tool that scales from simple string responses like this to complex workflows. While this example is synchronous, the same decorator pattern supports async operations and interactive flows in more advanced use cases. FastMCP tool exposure. The FastMCP tool decorator exposes Python functions as remotely callable tools, using type hints for automatic schema generation and docstrings for interface documentation. The function signature serves as both implementation and interface definition, with FastMCP handling serialization across transports like STDIO and HTTP. This pattern scales from simple synchronous tools to complex systems while maintaining the same core approach.
The decorator that adds no code writes the entire contract.